Hello everyone. Today we are going to discuss the fourth problem of AtCoder beginner contest 336, which is pyramid. So what is the problem? We are given a positive integer k. No, we are not given a positive integer k. We are given a positive integer n and an array a of length n. Now here is the definition. What a pyramid sequence mean? Okay, so a pyramid sequence means that it would be like something like that: 1, 2, 3, dot 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 up to k minus 1, and after k minus 1 it would be k minus 2 dot 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 1. So it is first increasing by 1, monotonically increasing, and then monotonically decreasing. Then the difference between two adjacent number is always 1. So that is called a pyramid number of k will be here and k minus 1 will be here. So this the definition of a pyramid of length k I have given to you. Now we are given an array a of length n. We have to find the longest pyramid. Longest pyramid, what you can say, sub array in the given array. We can perform the following two operations also. So what is the two operations? Choose one term of the sequence and decrease its value by 1, or remove the first or last term. Okay, so what are the two operations? Most significant operations are like we can decrease any element by 1. So let's say some element ai, we have some element ai, then from this ai we can have anything from 1 to ai. That's one thing you can observe. And the second observation is that we can delete any prefix or any suffix. Okay, so we can delete some prefix and or delete prefix and or suffix. Okay, so these are the two operations. First, we can change ai to anything from 1 to ai, or we can delete any prefix or any suffix. So what does this two operation mean? This two operations means that if we have some array like this, we have to check if this portion, if this portion can be a pyramid sequence or not. So any subarray could be a pyramid sequence or not. That's what we have to identify, because we can delete any prefix or any suffix. So for the easier solution, order of n square solution, what we can do, we can iterate over every subarray, and for every subarray, or I think this will be order of n cube solution, and for every subarray we can check if this subarray is a pyramid sequence or not. So how we can solve if a subarray or any array in general is a pyramid array or not. So let's say the length of the array is L, then we can check that the pyramid sequence, after converting it into the pyramid sequence, it will become something like 1 2. This is L, right? And L should be odd, because a pyramid sequence is of length 2k minus 1, so this has to be odd. So if we have some array of length L, the pyramid sequence after the operations will be like 1 2 3 dot 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 dot. I think this will be L, and after that it will be like sorry, it will be L by 2, right? Because the pyramid sequence is of length L, so it will be 1 2 3 L by 2 to 1. So let's take L as 5. So 5 by 2, if we take the floor, it will be 2. So it will be like 1 2 3 2 1. So it will not be L by 2, it will be L plus 1 by 2. So it will be L plus 1 by 2, right? I hope you got it. So for any array, how we can solve this problem? We can check that we have built the pyramid sequence, right? We have built the pyramid sequence. Now we have an array A. So for every element ai, we will check, let's call it as p pyramid sequence. So ai should be greater than equals to pi. Okay, that's one important observation. So let me discuss again that what we have observed till now. So the first observation is that from the given two operation, we can change any ai to 1 to ai, and we can delete any prefix or suffix. So our order of n cube solution, where we are iterating over every subarray, becomes what? So we will iterate over every subarray and we will construct the pyramid array. It will be like 1 2 3 up to L plus 1 by 2, then it is decreasing L plus 1 by 2 minus 1 till 1, right? Now we have constructed the pyramid array. Now we will check if every ai should be greater than equals to pi, then our answer will be yes, and otherwise our answer will be no. So that's the order of n cube solution. uh, how we can make it faster. Let's check the constants on n is 2 into 10 to the power 5. So anything like order of n or order of n log n will be acceptable. Here in we can't think about any order of n log n solution, because we can't really sort the array or do some kind of binary search. At least I am not able to think about some binary search or sorting solution. So let me discuss how I have solved the problem. So I have some observation, right? So let's consider some pyramid element will have some peak, right? Let's call it as p. So so what we can see that there will be some let's say we are iterating from the start of the array, so there will be some monotonically increasing sequence up to p. And if we iterate backwards, if we iterate from back, then there will be some monotonically increasing sequence from n to p, right? So there are two monotonically increasing sequence coming to p. So what if we try to build something called as prefix I? So what prefix I will give us? Prefix I will give us the maximum value of the increasing sequence we can build up to I, right? So let me give some example that will be more clear. So let's say we have something like 1 2 3 3 4 3 2. So we will try to build the prefix array. So here you can see that we can build 1, right? Now here we can build 1 2, here we can build 1 2 3, but now we can't build 1 2 3 4. So we have to build something like 1 2 3, right? So we have to discard this and we can build 1 2 3. Now again we can build 1 2 3 4, right? Now again we can't build 3, so we have to take these three elements 1 2 3 again. So 1 2 3. Now again we can't build 1 2 3 4, so we have to build take only this 2 1 2. So what is what will be the prefix I for each index of this array? So it will be 1, because we can build till 1. It will be 2, it will be 3 again. I have explained what does prefix I mean, that we can build 1 2 3 like up to let me clear the definition of prefix I again. Up to index I, what is the increasing sequence we can build? So it will be 1 2 3 3. Now it will be 4, it will be 3 again, and it will be 2. Okay. So similarly we will build the same thing for suffix I. So what suffix I will mean? For suffix I we'll just iterate backwards and the rest of the thing will remain same. So for suffix I, here you can see we can build up to one increasing sequence up to 1, it will be 2, it will be 3, it will be again 3, it will be again 3, it will be 2, and it will be 1. So this is our suffix. So this is our prefix array, and this is our suffix array. Now we will check for each element, we will try to make it as the peak. Now so if we try to make the peak, we can take prefix of I minus 1. So the peak will be like something like prefix of I minus 1 p and suffix of I plus 1. Okay. So what could be the value of p? The value of p could be either ai, or it could be either prefix I minus 1 plus 1, or it could be either suffix of I plus 1 plus 1. So we have to take minimum of these three, then we will get our answer. So for every index I, we will try to make it as peak, and we will take the minimum value of these three things: prefix of I minus 1 plus 1, comma ai, comma suffix I plus 1 plus 1. So let's jump into the code. So here I have built the suffix array, as suffix will be suffix of I will be minimum of ai, comma suffix of I plus 1. And similarly we are iterating over for suffix array we are iterating backwards, and for building the prefix array we are iterating forwards. Okay. So and our answer will be maximum of answer, comma minimum of prefix I minus 1 plus 1 plus comma ai, comma suffix I plus 1 plus 1. So and at the end we are returning or printing our answer. Okay, I hope you got my explanation. The problem is quite interesting. If you find this video helpful, please like the video and subscribe to my channel. I will provide the link of the code in the description box also, you can check that out. Please like the video and subscribe to my channel. Thanks again.